Polynomial equations. Here is a very beautiful question. Consider the function h of t equals to minus 5t square plus 9t plus 2, which approximates the height of the ball in meters as a function of time in seconds. In the division relationship, h of t divided by t minus b equals to qt plus r over t minus b, where b is a constant. Explain what qt and r mean, both geometrically and physically. What is the remainder when h of t equals to minus 5t square plus 9t plus 2 is divided by t minus 2? What does the remainder represent physically? Okay. Now, to do this problem, let's try to understand the sketch and the scenario. Okay, so let's think like this. First, let me graph this function approximately. So we have this as our function, and let's say at t equals to 0, somewhere it will be 2 here, right? So let's say this is the starting point at t equals to 0. So the ball is thrown upwards, so it will go up and then finally fall down. So let me just sketch it like this. And it comes here, like that. So that is a parabolic path. It's not so beautifully drawn, but kind of imagine that this is the parabolic path which the ball takes. And here we have t in seconds, right? And this gives us height of the ball, h of t in meters. Okay, now let's do part B first. What is the remainder when h of t is divided by t minus 2? So, well, the remainder when t minus 2 divides into this is h of 2, right? So we can find what h of 2 is. So h of 2 is equal to minus 5 2 square plus 9 times 2 plus 2, correct? 2 square is 4, 4 times 5 is 20, so we get minus 20 plus 18 plus 2, and minus 18 plus 18 plus 2 is 0. So at 2 seconds the height is 0, so that means this point is 2 seconds, correct, when the height is 0. Okay, what does the remainder represent physically? So remainder actually tells you the position or the value of the function at that time. Is that okay? So the remainder is 0. That means when t equals to 2, then the value of the function, or h of 2 is 0, gives the position. So in this particular case, it tells you, since the height is 0, that the ball hits the ground at t equals to 2. Okay, so it is in air for 2 seconds. So that is the way you can see t minus 2 or height at t equals to 2. Okay, so that's part B. Now let's get back to our division relationship. It says in the division relationship, h of t divided by t minus b equals to qt plus remainder r over t minus b. So what is b? So b is any point in between 0 to 2 in this particular case. So let us think that b is the time at this instance of time. So that means b is so many b seconds after the ball is launched. Let's say this point is b for us. Correct? So when we divide our function ht by t minus b, we get a quotient qt, and then there will be remainder r over this. Okay, what b represents actually is, so this is hb, so this point is b and hb, right? And so at b, when you divide this by this, that should be the remainder, correct? So that physically gives us the remainder r from here to here, correct? So ht, whenever you divide ht by t minus b, that means h of b is equal to remainder r, correct? So if I plug in b, then I'll give the position, right, of the ball at any instance of time. So that is my value, right? So it is h of b, which is r for us. Now, what I will do now is I'll rearrange this equation. So if I rearrange this equation, I get, let's find what is qt from this equation. So we have qt is equal to ht over t minus b minus, I'm bringing this on that side, minus r over t minus b, correct? Now t minus b is common, so I can write this as t minus b, and in the numerator I get ht minus r. Now ht minus r, what is h of t? H of t is height of the ball at any instance of time t. So in general, let's say this is my time t in general, okay? This is my time t, any time t. It could be b, it could be 0, it could be 2, it could be anything, right? So that is my h of t. So what is the meaning of h of t minus r? Let's see, what is the meaning of h of t minus r? So h of t, this is h of t is from here to here, right? So let me just connect this and tell you, and show you rather here. So from this point is t, h of t, correct? So h of t is this height. Height of the ball at any instance of time t, correct? Now h of t minus r is this height. R is the height of the ball at b, okay, when time was b, correct? Now what is h of t minus r? H of t minus r is this much. H of t minus r is this much. Do you see that? That is h of t minus r. And what is t minus b? T minus b is this much. Correct? That is this much. So what we can see from here, it basically, we have a triangle here. Do you see that? From this point to this point. Let's join. Where h of t minus r is the height of the triangle, and t minus b is the base of the triangle. Do you see that? We can also say this is run and that is rise. And therefore, this over this gives us the slope of the triangle. Do you understand? So this is the slope of a secant which joins any 2 points on the graph. So q of t can be seen as h of t minus r, which is kind of rise. We can write here as rise. And t minus b as run. So it implies slope of secant when from t equals to b to t. Do you understand? From time, any given time b to a general point t. Do you see? Slope of secant from b to time t. So that is the significance of quotient. So quotient in this particular case, or in such examples, gives you the slope of, or the average rate of change between 2 times. Any general point, any general time t, any instance of time t after the ball is launched, to fixed time b after the ball launch. Let's say after 1 second, if I put b as 1, then b will be 1. So after 1 second, what is the rate of the change of the ball at any instance of time? So in that case, ht will be that any instance of time minus h of 1. Okay, so that is how we relate it. So remember, remainder r gives you the position of the ball at any instance of time, and quotient qt provides you with the slope, or the average rate of change of the ball, in this case the ball, between the 2 given times. Thank you.